Welcome to a quick lesson reviewing some concepts from right triangle trigonometry. In this first video, we're just going to discuss just some of the terminology, the variables that will come up, the labels, and the basic identities, the equations from trigonometry. So the most important thing as you're working your way through trig, if you've gotten used to using our guess process of givens, unknown, equation, and solve and substitute, then you can use that here too. But for that to work, you have to be familiar with what the variables are, what the terms are. So we have a right triangle here, and if you were strictly following what you would have in geometry class, you'd say that's not a right triangle because this has not been labeled as a right angle. Well, one of the things in this class is if it looks like a right angle, we're going to say close enough because we would rather have an imperfect estimate than no information at all. So we accept that we will have some imperfect numbers when we do our calculations, and we know just not to be overly confident in the accuracy of our numbers. Okay, so we have our right triangle here, and one of the first things that throws people off is this variable right here, theta. That's just the Greek letter theta, and we use that as a generic variable for any angle, just like in algebra class, any unknown, when you're starting out, any unknown is just x. Well, theta is our go-to variable for angles. So on any time we use a right triangle, we're going to label one of the corners with theta, and it really depends which one. It's not always the same corner. So in this triangle, it's up here. In this triangle, it's here. It can be any of the angles on our triangle. Now, for it to be useful, generally it's not one of the right angles. So theta, we have that marked. And relative to theta then, we are going to have one side that is opposite and one side that is adjacent. Adjacent as in touching. And the one that we haven't mentioned so far that should be familiar for a right triangle is hypotenuse. The long side, the longest in fact on the whole triangle, that is across from our 90-degree angle. So opposite, adjacent, and hypotenuse. And we've worked out through the centuries just a series of ratios, and we've found that it's useful to talk about the sine of theta, and that is just the ratio of the opposite divided by the hypotenuse. The cosine of theta, which just means on a triangle, it's adjacent divided by hypotenuse, and the tangent, which is just the opposite divided by the adjacent. Okay, so these are the relationships that we use, and that we can bring these functions in. There's some useful stuff we have on our calculators involving sine, cosine, and tangent. But that's all it is. It's just the ratio of these sides. Now, on a right triangle, you probably remember from geometry class that we also know that the two legs, a squared, a and b, add up to the hypotenuse c squared. So a squared plus b squared equals c squared is the Pythagorean theorem. So in this context, what that's saying is opposite squared plus adjacent squared equals hypotenuse squared. It doesn't really matter which one we label a and b, but opposite and adjacent, just to put it in the same context of labeling that we have, we can just say opposite squared plus adjacent squared equals hypotenuse squared. So these equations are all we're going to need to work out a whole bunch of ratios. So it can help us a lot. So in the next video, we'll talk about how to use those.